Okay, so hopefully you've watched the video of the basic trig functions, the introduction. If not, go back and watch that first, because that gives you the information you're going to need to use for this video, which is to find missing sides and angles of a right triangle using our trig ratios. So we're going to start with talking about how you can use your calculator to help you out here. You are going to need it for a lot of questions. First of all, because we have a lot of fractions and decimals, but also because you have those buttons on your calculator that will give you some trig values. So you have the buttons sine, cosine, and tangent. We've already talked about those abbreviations, sin, cos, and tin for sine, cosine, and tangent. And we're going to use those buttons on our calculator. So if you've got your calculator, find those buttons on your calculator. Also, make sure that your calculator is in degrees, okay? So put your calculator in degrees. Okay, so check your mode. Depending on what type of calculator you have, there's a different way of going about setting that. But make sure that it's in degrees. For not so fancy calculators, there's usually just a DEG somewhere on the margins of the screen that you can use to check that it's in degrees. So check that, and then come back when you have it all figured out. So pause the video if you need to do that. So once you have that, we're going to use it to find the values from a triangle, and we're going to find those values to the nearest tenth. So we're going to be rounding our answers here. So let's start with this triangle here, and we're going to start with the values that we know and the things that we have, and using our trig functions to find x and y. So you'll notice that first we can't use Pythagorean theorem because I only have one side length that I know. I can find my angles, but I need to know my side lengths. And this isn't one of my special 45, 45, 90 or 30, 60, 90 triangles. So I have to use a different method here. This is where our trig functions come in. So starting with the angle that we know here, 25 degrees, okay. Yes, I could also use my other angle. Okay, I know this one down here is 90, so I could find that other angle and use it if I wanted to. But I've got 25, so I'm going to use 25. Label your sides. So remember, once you have your angle that you're using for reference in your triangle, label your sides. This is going to be my hypotenuse. This side down here is my adjacent side. And all the way across here is my opposite side. So then remember our trig functions. So, toa. We're going to be using those. So I'm going to start with my 25-degree angle, and I'm going to use one variable and one other side that I know. So if I want to start here with x, x is my opposite side, and then I need a side that I also know. So 20, which is my hypotenuse. So if I'm going to use opposite and hypotenuse, I need to use sine. So the sine of my angle, 25, equals opposite, x, over hypotenuse, 20. Okay, the very end of that first basic trig functions video, we did this. We wrote this formula. So go back there, I kind of talked about it a little bit there as well. Once I have that formula, I can use that formula to solve for x. So remember I said before that the sine of 25 has a value. You don't know it, I don't know it. The calculator knows it though, because my calculator is very smart. And so I can solve this has a value, and I can, to find x, I need to get x by itself. So I can multiply both sides of my equation here by 20 so that I have x by itself. So my suggestion is to always work this out on paper first before you jump to your calculator. So write this out on paper first, 20 times the sine of 25. Then go to your calculator and put this in your calculator in one step so that we're not rounding answers that we then plug in and round and plug in and round, so that we're not getting a bunch of rounded answers. And when we plug that into our calculator, your calculator is going to automatically put parentheses here after sine so that you can get your 25 inside of those parentheses. And when you plug that in, you should get for x, you should get approximately 8.5. Okay. It's not exactly 8.5 because we're rounding to the nearest tenth, but you should get a value that rounds to 8.5. Okay? So that's x, and I'm done. I've used my trig function, I've used this formula here, I've used the trig ratio to find my value of x. I'm going to do the same thing to find my value of y. Y is my adjacent side. I need another side that I know. Let's not use a rounded answer. Let's use an exact answer like 20 for my hypotenuse. So if I want to use adjacent and hypotenuse, I need cosine this time. So the cosine of 25 equals adjacent, which is y, over hypotenuse, which is 20. And so again, I multiply by 20 on both sides to get rid of the 20 on the right. And I can take my calculator and plug in 20 times the cosine of 25. And I'll give you a minute to do that. And when you plug that into your calculator, you should get, again, this is approximate because I'm rounding, we should get 18.1 as our approximate answer for y. Okay? So that's how we use our trig functions to find the missing sides of a triangle when I only have one side, but I know one of my angles. Here's another example. I'm going to let you do this on your own, so pause your video and do the work here and come back and check. If B, not B, angle beta, that's Greek letter beta, is 56 degrees right here, I want you to find x and y, the side lengths of this triangle. Okay. So pause your video and do that. I'm going to give you the answers here in 3, 2, 1. X equals approximately 9.9 and y is approximately 6.7. So if you didn't get that, again, pause the video, go back, do the work, maybe rewind to look at the last example, and come back and see if you can find how to get that answer. Okay? All right, next example. We're finding the value of x here to the nearest tenth. I'm going to get you started on this one and let you do the rest of the work in your calculator. Here's our angle. The sides I have are adjacent and opposite. So if I look at my trig functions, I'm going to have to use adjacent and opposite, which are here in tangent. So I'm going to have to use the tangent of 35 equals opposite over adjacent. So then solve that in your calculator, and what you'll get as your answer is x is 7.0, and it just kind of works out that it's rounds to 7.0. It's not exactly 7, but it is fairly close. So kind of using that example, go ahead and do this one as well. Find x given that alpha is 21. So again, pause your video, do the work, come back and check your answer, which I'm going to give you in 5, 4, 3, 2, 1. X is approximately 78.2. I believe it's 78.15, so we'll go ahead and round that to 78.2. So this is how you find side lengths when you are missing one side but you know one of your angles other than your right angle in your triangle. So then the question is, can I find the angle? And the answer is yes, we can find the angle. On our calculator, we have to use another set of buttons to find the angles. These are called our inverse trig functions. Those inverse trig functions are found right above your sine, cosine, and tangent buttons, right up here with the little sine to the -1, cosine to the -1, tangent to the -1. Those are your inverse trig functions. So we use those when we know the value of the function. So I know what sine equals, but I don't know the angle. So think of it kind of like we do with squares and roots. If I know the square, but I need to know what that root is, I use the square root button. So if I know the value of the trig function, but I don't know the angle that went into it, I use that inverse trig button. So let's look at an example to explain how those buttons work. If I want to find alpha in this triangle to the nearest degree, so I want to find alpha, let me use that angle as my reference. Then my sides that I have are my adjacent and my opposite. So the trig function I'm going to use, which has opposite and adjacent, is tangent. So just like we just did, I would write this function out. Tangent of my angle. In this case, my angle is alpha. Tangent equals opposite, 6, over adjacent, 8. So if I know that the tangent is 6 over 8, I want to find the angle. So I use that inverse tangent button. So just like if I have squares and square roots, I'd take the square root of both sides. I kind of do the same thing here. When I take that inverse tangent, it gives me back just the angle. On the right side, the inverse tangent of 6 over 8 is what I would plug into my calculator. So I'm going to take my calculator. You're going to have to, if they're above those buttons, you're going to have to use your second key. So second tangent gives me that tangent with the little -1. And I can put this fraction in my calculator, 6 divided by 8. Because remember, it's in the parentheses there. That's one of the reasons your calculator gives you those parentheses. So then close the parentheses and hit enter. And it's going to tell you that alpha is approximately 36.869, etc. So if we round that to 37 degrees, I want the nearest degree. So alpha is 37 degrees. Once again, just like I said before, try to do that all in one step in your calculator. Try not to take time to plug different things in different steps. Just put it all in once and get your one answer. These are fairly simple, but it's a good note for always. Do as little steps in your calculator as you can so that you're not rounding a lot of answers. Okay, so that's an example there. Let's go ahead and look at the next example, and I'm going to do the first part of this and then let you work on the second part kind of on your own, and I'll just give you the answer. So if I want to find alpha and beta to the nearest degree, so let's start with alpha. I'll do alpha and then I'll let you do beta. So alpha, if this is my angle, then the sides that I have are hypotenuse and opposite. So the trig function I'm going to use that uses opposite and hypotenuse is sine. So the sine of alpha equals opposite over hypotenuse. But again, I don't know the angle, but I know the function. So in order to get the angle, I'm going to use the inverse trig function. And you could simplify that fraction 22 out of 40 if you wanted. Type it into your calculator as 11/20ths maybe, or just leave it 22/40ths. Your calculator is smart enough to know what to do with it. So if I plug that into my calculator, it tells me that alpha, that's a crazy looking alpha there. It tells me that alpha is approximately 33 degrees. Okay. I do want you to do the work for beta. I know we could just subtract it from 90, but go ahead and take a minute to do your work to find beta. Pause your video and do that. I'm going to give you the answer here for the value of beta in 5, 4, 3, 2, 1. Your value for beta is approximately 57 degrees. Okay? So if you don't get that, go back and try it again. And then I have one more example for us, which would be this one here. So for this example, I want you to find the value of theta to the nearest degree. Label the sides, pick your trig function, and solve for theta. Do that on your own. I will give you the answer in 5, 4, 3, 2, 1. Theta is approximately 67 degrees. So that's it for our lesson here, using your trig functions to find angles, to find sides. If you'd like to post any questions, I'd be happy to work these examples out for you in another video. All right, but there you go, using our trig functions.